So if you go here and see, we have two types of virtualization. One is the type 1 and type 2 hypervisor. This is providing virtualization capability. What happened in type 1 hypervisor? There would be hardware. On the top of hardware, there would be hypervisor. Hypervisor is nothing but it is kind of software. So on the top of hardware, hypervisor is going to be installed. And on the top of hypervisor, there would be operating system. Now on the top of operating system, there would be application. Okay, that's a type 1 hypervisor. There is type 2 hypervisor. First, you need to install hardware, then operating system, then hypervisor, and then on the top of hypervisor, you can install the application. So I'm using same thing. I'm using type 2 hypervisor. What I did, I purchased the laptop. On the top of laptop, I have installed Windows 11. And on the top of Windows 11, I have installed hypervisor, which is VMware. And on the top of VMware, I have installed another operating system, which is Linux operating system. So what I'm doing a virtualization of my physical hardware.
Hypervisor is the VMware?
Yeah, I mean, yeah, VMware is an example of hypervisor.
Okay.
It could be Hyper-V, VMware, or VirtualBox.
These are the examples of hypervisor.
Yeah.
And on top of this, we will again install the operating system.
Yes.
Okay. And in that operating, again, example, you already have Windows 11, you said. So on hypervisor, again, you will install Windows 7. And then on Windows 7, again, you can install anything like Java,
Yeah.
any application. Okay.
Correct. So I'm going to show you. This is the screen which you are right now able to see. This is the screen of my physical hardware, right?
Okay.
And if I open this VMware, this VMware is what? This is a hypervisor. This VMware is a hypervisor.
Okay, VMware.
Inside the VMware, I have installed Linux operating system. So okay. This is the another operating system. And you can see on this particular machine, if I go to manage option, sorry, settings, let it to be on.
Yeah.
So this is Linux machine. And if you see on this Linux machine is running on the top of CPU and memory. And if you want to see the virtual, virtual infrastructure, so you can see in this machine, I have a memory, which is RAM. Mm-hmm. I have a processor. I have a hard disk, virtual hard disk, virtual processor, virtual hard disk, virtual CD and DVD drive, network adapter, virtual USB, virtual sound card, virtual printer, virtual display adapter. All these things we have on this machine. And you can see on my base machine, I have 8 GB of RAM on my base machine right now. Okay. And out of 8 GB, 2 GB I have allocated to this virtual machine, this Linux operating system.
We can customize as per our requirement.
Yeah, we can customize as per our requirement. If I need to increase or decrease, yes, I can do that. Okay. So, this is a machine level, computer level virtualization, right? We are doing a virtualization on server or maybe on computer.
Okay.
We have the virtualization concept in router as well. So in router, let's say I have a single router, but that single router, I just want to serve for 3 different customers, right? So what I can do, I can use a virtual route forwarding, where I can segregate the routing table of both or all three customers using the VRF concept. So you can see VRF is another example of virtualization. Here, what we are going to do, this would be the physical router. This is a physical router, which is going to run three different, VRF. One is blue. I can give the name any name. So I have taken here color as well. So blue VRF, let's say blue VRF, this VRF is for customer A. This would be for customer B. This VRF is dedicated for customer B. And this VRF is dedicated for customer C. So we have different VRF where routing would be different. Whatever, infra is connected over here, their routing would be different. Okay, that we are going to learn in the VRF phase. Okay, but what we are going to do, we are going to do a virtualization on router level, and also we can do the virtualization on switch level using a VDC concept, virtual device context. And earlier I told you, instead of purchasing 3 switches for core, aggregation and access layer, you just purchase one switch, and with that one switch you can create a 3 different VDC. So that's the virtualization. We will learn all these concepts.
Last time you said VDC, virtual device context. We have taken the Nexus 7K switch, and we have created that 3 thing, right? External, internal, and some corporate. And then this thing, if you want to leak the traffic between each of the VDC, you have to play with the routing protocol, something you said, right?
I said that using admin VDC, you can manage the port, etc. And directly there won't be any connectivity between one VDC to another VDC.
Yes,
you
correct.
Can go via externally only.
External protocols, routing protocols.
External cable you have to put between 2 VDC.
Cable. Okay.
Yeah.
This VDC concept we're gonna do afterwards.
Yeah, we will do this VDC concept. Okay, so that's the virtualization. We will, I mean, why we have taken this virtualization topic, because as infrastructure you could have a physical infrastructure and you could have a virtual infrastructure. So when you come into the virtual switches, which is your Nexus switches, so over there you can create a VDC. And if you are going for virtual router, so definitely you are going to learn the concept of VRF. So that's what this is. Don't worry, we are going to talk about this. Okay, we are going to talk about virtual circuit as well. Virtual circuit is nothing but your GRE and IPsec tunnel. That is a virtual circuit. And physical circuit, your MPLS broadband is a physical circuit, and that's a virtual circuit is what? Tunnel, basically. So we will talk about that as well.
Physical circuit, you said MPLS and broadband. Virtual circuit is the tunnel, and internal we have GRE or the IPsec over GRE, right?
Right. Tunnel you can use IPsec, GRE, or DMVPN. All those is a all those are the virtual circuit. But even though your frame relay as well, your virtual circuit.
Virtual circuit.
Yes.
But if you say by IPsec is the tunneling, or IPsec is just for the security purpose? It's not as a tunneling.
It's a tunneling plus security purpose. It's serving both.
Both. We can say tunnel plus security. Okay.
Yeah. So why we are saying security? Because it is doing encryption. Okay. With the with the tunneling, it is doing all the encryption. That means whatever data is traveling in between IPsec tunnel, all the data would be encrypted.
Okay.
Yeah.
One more question is there in my mind.
Mhm.
Yesterday you said, right? We have that thing yesterday or last time. We have switches in the stack. Stack you said, right?
Mhm.
One
Yeah,
switch
stack
is
switches.
connected to
Yes.
stack switches.
Mhm.
Instead of doing the stack switch, we can just put the uplink of the switches, right? Both are the same thing, or it's a different thing.
Yeah, both are the same thing. You can
Hmm.
use uplink as well. I mean, both is serving the similar purpose. Okay.
Hmm.
Basically, it is creating one switch itself. Using uplink, you can connect another switch, layer two switches. You can do
Mm-hmm.
that.
Yeah.
Yes. So that's also possible. But a stack switch having a dedicated stack cable. It is not using Ethernet cable. It's a dedicated stack cable. I can show you stack switches in this diagram. Let's see.
It's a very thick cable, if I'm not mistaken.
It is kind of cable. This is the stack cable.
Hmm. So this first switch is connected to the fourth switch,
It can
and
it can
also,
use this cable as well. Yes, you can see here how it is connected. First, the switch is connected to fourth switch. Fourth switch is connected to third switch, and third is connected to
second,
second,
as
and
well
second
as
is connected to first.
like partial redundancy is there, right?
Yes.
Redundancy
Yeah.
is there.
Yes.
Okay. So same way we can do the uplink also instead of doing this thing. But you said stack switch. Maybe this stack is having high throughput,
Yes. Definitely, it has a high throughput.
gig or something,
Yes.
1000 MB. Okay, okay.
Correct. And you would see if you work in the data center, so it
Hmm.
would be your day-to-day job to put these kind of stack switches. I mean, whenever the new device is getting racked on the data center,
Hmm.
so definitely I mean, 40 to 60%, there are chances that you would be putting stack switches over there.
Uh, Basically, this stack switch, if you say so, it's a good practice to use stack switch, but other than the just doing the uplink. Is it
Yes.
correct? Okay.
Correct.
The recommended thing is the stack switch, then the uplink.
Yes.